All right, welcome to the last section of Chapter 5. This is Section 5.6, and we are going to kind of finish talking about chemical reactions and how things happen in a chemical reaction. And the big thing that happens in a chemical reaction is energy. Energy is required. Just like when you bake a cake, right? What do you have to do? Typically, the cake, you mix the ingredients together, and what happens? It sits there and you have to add energy to it, right? Usually got to put it in the oven, you got to do something else to it. All right, energy is required to help bake that cake. Same thing with most chemical reactions. Energy is required in one form or another. So remember, chemical energy, there are 5, 10 different types of energy. And one of them is chemical energy, and chemical energy is ones that are stored by chemical bonds. Now, what we talk about here, the big thing I want you to get down is when we talk about chemical bonds and things reacting, two things take place. Breaking bonds requires energy. Breaking bonds requires energy, and forming bonds releases energy. So those two things down. Breaking bonds requires energy, and forming bonds release energy. And depending on whether you are giving off energy or accepting or absorbing energy depends on one of these two terms that we're going to talk about. And the first is exothermic. What is exothermic? Exothermic release energy into the surroundings. What does the word exo mean? The word exo means exit. So heat is exiting. Heat is exiting. And we have talked about exothermic and endothermic a little bit, but we're going to kind of review it again. So an exothermic reaction, heat is exiting its environment. Then we have endothermic. What does endothermic mean? Endothermic means it's absorbing energy, or what we call heat is entering. All right? Heat is entering. So you can kind of do that. So endothermic reactions absorb energy from their surroundings, which means that endothermic heat is entering. So exothermic heat is exiting. Endothermic heat is entering. And the last thing that's super important is the conservation of energy states that all energy is conserved in a reaction. That means if something loses energy, another substance has to gain energy, or vice versa. If another substance gains energy, another one has to lose energy. So that is super, super critical. Just like conservation of mass, where mass does not change in a chemical reaction, energy doesn't either. So energy is always conserved in a chemical reaction. So keep that in mind. So when we talk about energy, we have exothermic and endothermic. Exothermic heat is exiting. Endothermic heat is entering. And energy is always conserved in a chemical reaction. This is Mr. Kleinert, and I'm signing off.